Oh, hey, here's a meme for you guys.
Hi, girlfriend.
It's not saying it's me, guys. It's just funny.
Did you just make that, or did you find it?
No, I found it. It's like I've had that on my phone for like over a year.
Wow. Trust me, I'm trying.
I think it's funny. You can also say VF if you would rather. Okay.
Find GF. I've already found her.
Oh.
Okay. Dude, you have a girlfriend? Yeah.
We
Do
do.
you remember? That's funny.
Whoa.
Sorry. No, I just.
Crazy.
Yeah, I didn't mean it how it sounded. I didn't mean how it sounded.
Okay. So anyway, just a meme for laughs and giggles, guys. Okay. It fits in. I felt like it fit in pretty well with what our assignment was that we just turned in. Because that was basically the same kind of assignment, right?
Yes.
Not what I made. I just found it online. I thought it was funny. Okay. Hey, come over here on Trooper Tide Tuesday, the 27th of this month. I know this cover's a little hard to read. I just haven't been able to write it yet. SWBA. What's the SWBA stand for?
Student will be
able
to.
Student will be able to. The T is silent. Get it? It's not supposed to be silent. It's a joke. Anyway, okay. SWBA. Okay. Student will be able to find lengths by using the distance formula and segment bisector. Segment 1.3. Section 1.3. I should say section 1.3. Okay. Woo! Okay. So, distance. Distance is also called length. Ooh, maybe if I spell length correctly, that might be better. Length. And always represented by a negative number or a positive number, okay? Just like we said the other day, okay? You don't drive to Bellevue from here and it's positive distance, then you drive back in this negative distance. That'd be weird, okay? Like the odometer on the car goes backwards, okay? If you go in reverse or something like that, it's still positive distance regardless of what direction you're going, okay? Now to find the distance between, this is a lot to write on this line, I'll be honest, I need to adjust that. So to find the distance between 2 points on a coordinate plane, woo! You see how it almost jumped out and killed me. Jeepers. That's hand-I-oop. Man, that thing has a mind of its own, okay? To find the distance between 2 points on a coordinate plane, Bruce, put it away. Use the distance formula. Okay, we'll use the distance formula. What's the distance formula, Mr. Consul? Great question, math students. We're about to find out. Okay? Anybody still need this? Ooh, not quite, no.
Can we have like a 2-minute break?
Okay, we just started our notes.
Yeah, we need a 2-minute break.
Okay, we'll do some sort of a break in a minute. Trust me, I gotta change it, okay? So distance formula. D, lowercase d for distance equals the square root. I drew a big square root, guys, okay? Botched it. x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared.
Are you serious?
What?
I am. And don't call me Shirley. You get that, Mrs. Oswald?
Yeah.
Thank you. Oh, yeah, it's like the airplane. Like, surely you can't be serious. I am. Okay, don't call me Shirley. But Shirley, you can't call me serious? The distance formula. I know what you meant. I just like the yank your chain. Okay? I'm just pulling your leg figuratively, but not literally.
Is there a
No, I'm
math
not topic.
No,
What was your question? Okay.
I just can't see. It's fine. I'll
Here, you want to borrow my glasses?
No, I don't.
Probably. Maybe they're a good idea. Okay. Hey, so is this x2 and x1? Is that like x squared? No, that's the second of two x's. It's like this is the first of two x's. Notice, do we have our x and y mixed up here and our x and y mixed up here? No, we have all of our x's together and all of our y's together. Okay. So hey, let's call this point x1 and y1. So what would this one be? x2, y2. Okay, great. Okay, let's practice finding the distance between these 2 points. Notice these 2 points, they're diagonal. Okay, remember last time if we could just count straight left to right, we could do that. Without some sneezes? Yeah. Bless you, must rain down half, bless you, forget. Bless you, must rain down half, bless you, forget. Was there 2 or 3? Bless you, must rain down half, bless you, forget. Okay. I'm joking. I joke, Mr. Carlson is here. Okay.
I just crossed one.
So, I know, you just told me. Okay, so, D is equal to the square root of, okay, what's x2?
Wait, but what if it's a negative number?
Okay, we'll come to that, okay? 3, I like to substitute in parentheses, remember? Minus comes next, what's x1? Negative 3, so I'm going to put a negative 3 in parentheses there, okay? Hey, now what did we notice about x2 minus x1? That's all inside of a parentheses. Let's put that inside of a parentheses. Squared. I like to put them in there because I think it's easier to deal with all of our negatives going on. You don't have to. I just recommend it. Okay?
Wait, where'd you get the negative 3 from?
So x, we call it x2, 3. Then we call this negative here x1. So where x2 is, we'll put the 3. And where x1 is, we'll put the negative 3. Yeah, good question. Thank you for asking. Okay? Then what comes next is our plus symbol. Plus. And now we have y2. What did we call y2? I heard it, 4. So we put 4 there. Minus, what did we call y1? Negative 2, so I'm going to put that there. And just like with the x's, we have that inside of the big parentheses. And we have that being squared. That's all under the square root. Okay. So everybody to have this down, I want everybody to have this down, we'll talk about solving it, okay? So this is how we plug things into the formula. This is how we plug things into the formula, okay? Practice with that. Practice with substitution. You guys did this a bit in Algebra 1, okay? As well. Okay, especially when I remember with the quadratic formula. If you had me for Algebra 1, you got to learn the quadratic formula song, okay? That was fun, right? Okay? I know last class I was teaching this, and they were like, some students I had in Algebra 1 started singing the quadratic formula song. It made me real proud, okay? Let's be honest. Any of my students want to sing it now? Look at it. Look at 3, 4 of you. Okay, no.
X is equal to negative.
B plus or minus the square root of b squared minus 4ac all over 2a.
I thought I was supposed to sing.
Well, then you stopped.
I thought. Next, you interrupted me. It's fine.
He was gonna join along in the singing.
Whatever.
I'm going for a solo career,
Oh, okay.
not a duo.
Okay. So once we have this, let's go through and let's start simplifying this. Now we just follow our normal order of operations. We just follow our normal order of operations here, okay? Order of operation tells us to do what first? Parentheses! Okay? So we look inside the parentheses. We want to do the innermost we can, okay? So inside this parenthesis, what can we do? 3 minus a negative. Hey, what happens when we have minus a negative? It's like a positive, right? We have 2 negative signs in a row. It's like a positive, okay? So we can do like, we keep the d equals square root. What's 3 plus 3? 6, okay? And we still need this to be in one set of parentheses now. We still need this big set of parentheses. And what's outside the big set of parentheses?
Another
That exponent, that's 2, okay? That's squared. And then we have the plus sign. Now what can we do inside of this parenthesis? Can we do the same thing? Okay, those 2 negatives, that becomes a positive, and 4 plus 2 is 6. Very good, Marissa. Okay? And we also have this 6. We have to put it in parentheses here. And we have to square that. Okay? So we should all be here now. We should all be here now. If you're not, say something. Okay? Okay? So now our order of operation tells us, okay, is there anything we can do inside of this parenthesis?
Yeah.
Can you do something just inside the parenthesis? No. Okay, so we move to the next step. What's the E? Exponents. Are there exponents we can do? Let's do those. What's 6 squared? 36. Because 6 squared means 6 times 6. Okay, so 36 plus, can we do this exponent? 30. Oh, 6 squared is 36 every time? That's pretty cool. Okay, so now we have to continue doing this addition. What is 36 plus 36? 72, okay? Now we have the square root of 72. Do you guys know the square root of 72 off the top of my head?
No.
Me neither, okay? I'll be honest, I don't even know off the top of my head, okay? And I teach this stuff. And I can probably look down and be like, oh, okay, that's what it is.
Wait, is
I
it
have it.
9?
What?
No,
not
it's
9.
going to be a decimal, right?
It will be a decimal, okay? It's between 2 numbers. Because what's 8 squared? 64. Is 64 less than or more than 72? So it should be bigger than 8. What's 9 squared? 81. So should it be between 8 and 9 somewhere? Yeah. So we know it should be approximately. Okay, round to the nearest hundredth. This symbol right here, it's kind of like an equal sign, but it's approximately. It's not like super straight because it's not sure that it's equal. It's close to it. Okay, it's going to be approximately 8 point something. Let's figure out what it's going to be. Okay. Hey, permission to get out your phones. Okay, permission to get out your phones and or a scientific calculator. So if you have a scientific calculator you have or your phone, I give you permission right now to get it out. Okay, I give you not Siri. I give you permission to get it out and go to your calculator. Okay, I give you permission to get it out and go to your calculator. Okay. So right now you have permission to get on your phone, get it out, and go to your calculator. Okay, does anyone need a calculator? Does anyone need a calculator? Someone doesn't have it, they don't have a phone, whatever, don't have a phone, anything like that. Anybody need a calculator? Okay, I have a calculator over here for you. Okay? Okay, I'm going to teach you how to do it real quick, okay, if you don't know, okay? 8.485. Well, don't blurt, don't blurt, don't blurt, don't blurt, don't blurt. It is nice to meet you. Alright, so I'm going to walk through a couple different ways of how to do it, okay? First, the iPhone, okay? The iPhone would be different than Androids, okay? I hope you don't mind that I use your phone. The iPhone, okay? You have to type in your number first. You have to have it turned sideways. Type in your number, okay? So type in 72. 72. Okay? And then, on the far left part of the screen, if you go one row over, far left, one row over, okay? Okay? So iPhones should only be turned sideways now, right? Okay, so we're in the calculator, okay? So second row over, halfway down, you see a little X? You see a little X? It looks like this. You see that button? It should look like that. Okay? Tap that button. And it square roots it for you. It square roots it for you, okay? Okay, don't blur, don't blur, don't blur. Does anybody have a non-iPhone in here so I can show you that one, okay? I'll show you that. That one works very similar to our scientific calculator, okay? So the way you do that is you would, you also need to turn it sideways. You have both your rotation on. Oh, you should have rotation on. There you go. Okay, you need to push this button, and then you type in 72. Equal. Okay? So Grace, what you would do is you would type in, you would turn it on, and then you go to second, and right above x squared, there's that square root button. And then you type in your number and push enter. Does that make sense? Okay, so what you would do is you would type in 72 first, and then go to second, okay, and then your button, actually not second, your button without second is right here. And that would do it for you. So type your number first and then that button. Okay? Does anybody still need help?
My parents are
Okay. To the nearest hundredth, how many decimal places is that to the hundredth? 2. Okay? To 2 decimal places, the hundredth. Well, what's our answer approximately? 8.49. Remember, it says 8.485, right? You round up. Okay, so it's 8.485. You round up from the 5. The 5 tells you to round this one up, so it's a 9. Okay, so it is exactly the square root of 72, but it's approximately, it's close to 8.49. We had to cut it off, so it's approximately that. Okay, questions on that? Now, this formula, was this formula high-level math that we just did? No. Okay, the new part for us was plugging it into the formula. But did we know how to do the adding and the negatives and the squaring and the square root? Do we know how to do that stuff? Yeah, we do. We did that stuff before. Okay. The new part for us was using this formula. Okay. The new part was using that formula. Okay. What I want you guys to do is I want you guys to, on example 9a, to try setting it up. Okay. You don't have to finish solving it yet. I want you guys to try setting it up. Okay. So get it set up in the d equals, and I want you guys to try having it set up. Yes.
Do we have to remember this?
Did you go see Chance the Rapper? Did you go see Okay, good luck. I feel like we like the Titanic, you know. When I was in college.
Somebody go behind him.
When I was in college, no. When I was in college, one of my friends and I did that, and like someone played the song and put it on Snapchat. It was pretty great. I saw the video actually. You should show us. I'll do it one of these days.
You have this time. Oh my goodness.
Hey, can somebody tell me how you set this one up? Somebody want to volunteer how to set this one up? Okay, Gracie.
I don't really know what I'm doing. I kind of just guess.
Okay.
I think it's X, Y, X, Y. You have to figure out. So the 5 is X.
Okay.
So we can start with that, I guess. -5. And then 8.
Okay, what's going between those two?
Add. You're gonna subtract. Maybe.
Wait,
What was
how do
it?
you
And then you gotta set up your Y's.
Okay, but what do you have to do with these? Square. What goes between, then what goes next?
Add addition. And then you gotta go 6. And then -4. Parentheses squared.
Very good, that's all under squared, okay? Hey, does anybody have it set up differently? It's okay if you do. Celeste, what do you have?
I did the same thing, but the 8 and the 5 were switched around, and so was the
Sorry.
Okay, great. So Celeste, yours looks like that. Okay, Emily, is that how yours looks? Okay. Does anyone's look differently than these two?
I mean, I did it wrong.
You know you did it wrong?
Yeah.
How do you know?
Cause I put an X and a Y together
Okay.
instead of an X. Yeah. I finished and then I realized that I did that.
Okay. That's not stock, that's these. Okay. So, we'll talk about how either of these work, okay? So let's go through, and I want you guys to practice solving, okay? So I want you guys to go through and however you set it up, I want you to solve it, okay? So either way you set it up, like one of these two, I want you guys to solve it now, okay? So go ahead and work through, solve it, and if it's not a perfect square, I want you to find the approximate as well, okay? So you guys can go through and solve it just like we did on the first example we all did together. When you finish, I want you to compare with somebody next to you.
I have. Oh. Sorry. I was gone. Like, I was not in the room while we solved it last time.
She's gone.
If you're done, okay, compare with somebody next to you if they're done. If they're not, wait. Okay, Brayden, are you done? Yeah. Okay, Celeste, are you done? Yeah. Boom, compare. Okay. No. Yeah, well.
I was in this
Some form of this one is okay, but some
Yeah,
form
you
of
need
this
to
No,
check
it was
Kyle.
what?
this one.
Are you gonna be here with us?
Well,
What
there's
you doing,
part of
baby?
it-
Well, the
Buddy?
Food?
part of it that
Help
we-
Kyle?
that has to talk about Charlotte.
Are you sure about that?
Why do I remember that?
Yeah.
It's fine. My secret safe with you. Or my secret safe with you.
Okay, when you're done, compare at a reasonable volume with somebody
Wait, I
next to you.
forgot how to do it on the calculator.
Basically, push that second button.
I think I need to use the calculator.
Okay, yeah, I got it.
I was
You need to calm down. You're being too loud.
Okay, take it easy. supposed to put x2 first.
I just.
Oh, I got that too.
Keep your last, they say.
My, soon as mine's right. Yeah, right.
No.
About that up here. I don't know.
I'm pretty sure mine's correct.
Randy's like,
I'm doing copy on
okay, let's go over this up here, okay?
Okay.
So if we solve the left way first, okay? Solve the left way first. What's negative 5 minus 8? Negative 5 is going to be more negative.
So negative 13.
Negative 13. We put it in parentheses. It's important we have it in parentheses, guys, and we square it. Then we have this plus sign, so we have plus. What happens when we have these two minus signs in a row? Change it to add. Okay, I heard someone say keep, change, keep the first number, you change the sign, Okay, that's some way that some ways that some of us have learned it. What is 6 plus 4 then? 10. Very good, Ian.
Oh,
Okay, then we put it in parentheses and square it. Okay, we put it in parentheses and we square that. Okay? Now here's why it's really important we put it in parentheses. What is negative 13 times negative 13? Positive 169 now. Okay? So we have to make sure we have it in parentheses to make sure we make it positive. So it has to end up positive. What's 10 times 10 or 10 squared? 100. Okay? You can say like it's like 100, you don't put the symbols below it. Just kidding. Okay. Thank you.
I don't know how you got that.
Okay, we'll slow down in a moment, guys. Breathe. What is 169 plus 100? 269. Okay, now we need to find the square root of that. And it's approximately
You're not talking.
16.4, okay? It'd be 16.40 or 16.4, okay? If you didn't get this, raise your hand now so I can help you. If you didn't get this, raise your hand now so I can help you. Grace, what did you end up getting? You got
10.4.
You got the square root of 109, you said?
Yes.
Okay, so did you get this to be 3 instead of 13?
Yes.
Okay, so does it make sense why it would be negative 5 minus 8 becomes negative 13?
No.
Okay, did you have negative 5 minus 8? What did you have right there?
I had negative 5 plus 8.
Right, so we have to do one of the
I thought it
x's.
was keep change change.
Originally this 8 is positive, so it starts out positive instead of negative. Now if you had done it the other way, over here, 8 minus a negative 5, then it's a keep change. Okay, but either way, we end up with a 13 there. Okay, so that'd be what happened there. Emily, same thing. Okay, so the important part is we're realizing, oh, that's what I need to do next time. Okay, it's not like, oh, I'm done forever. I'm gonna be terrible at math. No. We all make mistakes. I make mistakes. Okay? It happens. Believe it or not, I still make mistakes. Well, no way. Okay. And so the important part is we're realizing what we're doing and we learn how to do it better. Okay. Any other questions on this first? On how we do it the first way? Okay. Let's look at the second way here. Okay. Celeste, you did it this way, right? Did you still get the same answer? Yeah. Okay. So let's look at this. Even if we switch up the numbers comparatively. 8 minus a negative 5, keep change. 8 plus 5 is 13. If you did not have it this way, you don't have to write this down right now. So it becomes 13 squared. Plus negative 4 minus 6. Negative 4 becoming more negative, negative 10 in parentheses. Okay? We don't change this to a minus sign. We keep this negative in the parentheses. That's very, very, very important. I added 3 berries for a reason. Okay? 3 berries for a reason. 13 squared is 169 plus negative 10 squared is? Negative 10 squared is? 100, okay? Hey, what's 169 plus 100? Are we going to get the same answer? Yeah, because is the square root of 269 going to be the same here as it is here? Yeah, okay. So does it really matter the order we have our x's? Does it really matter the order we have our y's? No. Can you switch up your x and your y though? No. We can't combine x and y's. So you can't put an x here and a y here. You can't put an x here and a y here. You have to have your x's together and you have to have your y's together. We have to keep those things together. You can have your x's in either order. You can have your y's in either order. we have to have your x's together and your y's together. Does that make sense? Grace. Okay. So once again, you have to have your x's together and your y's together. As long as you do, you can put the x's in either order and the y's in either order. That part doesn't matter. Because we get the same answer. Because whether you get negative 13 or positive 13, when you square it, it turns to positive. Whether you get positive 10 or negative 10, when you square it, it turns to positive. Okay? Questions on that? Okay? I want to talk through this third example real quick, but you guys don't have to do it. So I just want you to follow along with your eyes. So you want to follow along with your eyes and your ears up here, okay? You don't have to write this part down. So if I do distance of this, if I said that it's okay that we do the x's in either order. So I can do negative 1 minus 3 or 3 minus a negative 1. What do you guys want me to do? Okay, I'll do 3 minus negative 1 first. Now we said we can also do the y's in either order. Would you guys rather I do 1 minus 4 or 4 minus 1? Which one are we usually more comfortable with? We're usually more comfortable with the bigger number first. So let's put 4 minus 1. If we're more comfortable with that, let's go ahead. Now, did I keep my y's together still? Yeah, did I keep my x's together still? Yeah, that's what's important here, okay? So as I keep going through this, I have a keep, change, do negative become a positive. 3 plus 1 is 4, in parentheses being squared, plus, what's 4 minus 1? 3 in parentheses being squared. Okay, what is 4 squared? 16. What is 3 squared? 9? 9? What is 16 plus 9? 25. Hey, does anybody know the square root of 25? 5. So if it's a whole number 5, you don't have to write this as part of your answer. If it's a whole number, this is your answer. Is there anything to round? No. If you type this in your calculator, you'll just get 5. So this is your only answer, whereas here, because 269 is not a perfect square, like 25 is, you have to have both answers. Here, you only have to have the one, because it's already a perfect square. Questions over that? Gucci Gang, Lit Fire, Turn, Cash Money, Dope, okay? Let's go to the bottom of this real quick. Midpoint of a segment, okay? Hey, have you guys ever heard of dab push-ups? Dab push-ups, okay?
Yeah.
So dab push-up, okay? You guys had me in in class last year, you guys know, okay? Dab push-up. So, it's kind of like so I was at a camp a few years ago. I was helping out in an FCA camp, and I was like a small group leader for a bunch of freshmen and sophomore boys, okay? So around your guys' age, okay? Around your guys' age there, okay? Casey, can you put that away, please? Okay. Around your guys' age, and they were like, you know, like it was like a sports and FCA camp. So we're playing sports together, and so like you're like, whoa, like are you strong? I'm like, oh, I work out. And they're like, can you do a dab push-up? I'm like, a dab push-up. I'm like, is that like a clap push-up, like where you like go off the ground and you clap, but instead you dab? They're like, yeah, can you do it? I'm like, probably, I'll try. And I did it, and they're like, whoa, like that's so cool, like, you know, like I wouldn't want to mess with you and that kind of stuff. And so like that's how the dab push-up came to be. Okay, you guys want to see it?
Yes.
Okay, let me stretch a little bit here. Okay, I'm getting old, so I gotta stretch out a day or something. Okay. Ooh, I warm my dabs too. All right. Okay. So get in a good position to see. Okay, I'm only gonna do a few of them here. Okay. Make sure you're able to see here real quick. Okay. I'm only gonna do a few. That's a dab push-up.
Do you know what a Big Daddy is?
No.
They did that at my FCA camp.
I don't know what that is though.
In the lunchroom, like you do a push-up and then when you go up, you scream Big Daddy.
I mean,
Yeah, they made like a whole bunch of guys went on the tables of our lunch and then just started doing it.
that's quite the odd flex. Midpoint of a segment, okay? Midpoint. Okay, the point that divides the segment into two congruent segments. It divides the segment into two congruent segments. Divides it into two congruent segments. If segments are congruent, that means they are the same length, right? They have the same measure. Okay? So, if we're drawing a point in the middle, midpoint should probably be somewhere in the middle. I'm going to call that point M. Now I'm going to say point M is the midpoint of segment AB. It's in the middle of segment AB. So, segment AM is congruent to what segment? MB. Could we also call it BM?
Yes.
Sure. Either way. And that would also mean that the measure of segment AM is equal to the measure of what? The segment of MB.
Is there a little M by
Right here, yep. Great question. So there can so if point M is the midpoint, that means each of the two parts are halves. Okay? And does anybody remember, we talked about it very, very briefly last class, how we mark two segments are congruent?
An equal
Little
sign
tick
and
marks.
like a- What?
Little tick marks.
I thought it's a little squiggly thing.
That's congruent.
That's congruent. So that's like
Are we not?
this symbol right here. So the segments are congruent, but how we mark them on the picture is we mark them with these tick marks. And they both have one tick mark, so they're congruent to each other. That's how we mark it on a picture. Okay? You guys can ignore this parenthesis for now. Well, you guys can ignore the parenthesis just told, I guess. So if you guys flip the page, flip. Okay? Point M is the midpoint of segment BW. Point M is the midpoint. So that means it cuts this segment in half, right? It cuts it into two congruent parts. Is that what that tick mark means anyway? Okay? We're just asked to find the length of VM. Well, to find the length of VM, what do we first need to find? The value of what? X. To find the value of X, we can plug it in. Now to find the value of X, that means we need to set up an equation, okay? So if we work backwards, we need to find the length of VM. So we need to find X. To find X, we need to make an equation. Does anybody have an idea of an equation that we could set up? Okay, Colton?
You make them equal to
You do make them equal to each other, okay? If they're congruent, that means their measures are equal. That's what we just said. We said their measures are equal, so let's set the measures equal. If they're congruent, they're equal, so let's make them equal. Is this an equation we can solve? I think so. Okay? Skylar, what would be your math move that you would do here?
math.
Okay, what math?
I don't know either.
You don't know yet, okay? Think about it.
The X's.
Okay, what would you do with the x's?
Add.
Okay? Can you add them when there's an equal sign between them, though? No, so what do we have to do? We have to get them at the same side, don't we? Okay, so how could we move one of them? You don't know? You've never done it before in your life?
I don't remember.
You don't remember. Okay, do you want to phone a friend?
No.
Okay, Wyatt, what do we do? Not divide. Okay, what's this x doing? What? Subtract. We can subtract 3x from this side because what is 3x minus 3x? 0. And if we subtract from this side, what do we have to do to the left side? Also subtract the same thing. What is 4x minus 3x? X. We have x minus 1 on the left side equals just now 3. Okay? We had to subtract because it was being added with 3. The reason we had to subtract is because it's being added with 3. We didn't just pick that randomly. We saw it's being added with 3, okay? Okay? So now what do we do to get x by itself? We would add 1 because it's being subtracted. So negative 1 plus 1 is 0. So x equals what number?
4.
4. Now we said we could find x. So now that we found x, what can we do with it? Plug it in. Does it matter which one we plug it into? We need to plug it into VM, right? Okay. So plug it into VM. 4 times 4 minus 1. What is 4 times 4? 16 minus 1 is 15. So the measure of segment VM is equal to 15. Now what should we know about VM compared to MW? They should be the same, congruent. They should have the same measure. Okay? So can we plug in 4 to here to check that we did it right?
Yeah.
Let's plug it in to check. 3 times 4 is 12. 12 plus 3 is 15. So are they the same? Did we do it correctly? Yeah. What would happen if we got something other than 15? If we did it wrong, we can go back and check. We know. Okay? Questions on that one at all? Gucci gang. Okay, does anyone still need this up here? Okay. So, segment bisector. Segment bisector is a point, ray, line segment, or plane that bisects, intersects. I said bisects, it should be intersects. Intersects the segment at its midpoint. It intersects the segment at its midpoint. Now, a midpoint or a segment bisector, we say bisects the segment. Okay, let's break that word apart. Bisect. What's the prefix bi mean?
Both.
Two. Okay? Two. Okay, it means two. So like bicycle, two wheels. Okay? So two of something. S-E-C-T-S, sex. Okay? That means section. So it cuts it into two sections. In this case, we're talking about two equal sections. Okay? So that's what that word means. So if we break apart the word, that's what it means. Okay? So if I draw something here that cuts this in half, we're saying, I want you guys to draw that in. Yep, I want you guys to draw that in. Okay? And it needs to cut A, B in half. So it needs to touch that half of A and B.
Does that have to be exact?
Nope, just make it close. Yes, yes, yes. Okay? So we're saying that segment CD is the bisector of what segment? It cuts what segment in half?
M.
It doesn't cut M in half, but it cuts the segment AB in half. Very good. So that means what two segments are now congruent if this is all cut in half?
A, B, and C, D.
Not A, B, and C, D, but A, M, and
A, M.
B, M. Very good. That's cut in half. Okay? We're not saying anything happened to CD. We're saying CD is just cutting this in half. And so AM is now congruent to MB or BM. And so that means that their measures are also going to be equal. That means their measures are also going to be equal, okay? Now we could have drawn this at any angle. Okay, if you look at even the next two problems, are those at angle? Are those at different angles too? The segment bisector, what cuts it in half? Yeah. And it can be straight up. It can be at an angle. It can be anything. Okay. Let's kind of use this idea. Yes, Marissa.
What does that say? That one again, the one you pointed at.
At measure of segment BM. My M kind of came out weird. Thank you for asking. You want to put that away? Appreciate that. Okay. Anyone still need this before we move on to right below this? Okay, we're gonna practice one of these examples here. Okay. Gucci gang. Okay. Identify the segment of a segment bisector of segment PQ. Then find the measure of MQ. Two parts. Identify the segment bisector of segment PQ. Then find MQ. So what's cutting segment PQ in half? What's L? Is it a ray? Is it a plane? Line L. Okay, so I'll say that the segment bisector, I'll let you guys abbreviate to seg bis. Okay, segment bisector is line L. Okay, we have to have a lowercase l there. That's our segment bisector. So we answered the first question. We identified the segment bisector. Now, if this is cutting this segment in half, what do we know about these two parts? They are congruent, so their measures are equal. So how could we find MQ then? Who can help me out find MQ here? Sam, what are you thinking? This is an L. Let's see what's written down after we forget. Yeah, we're going to equal them again, okay? We're going to do 5x minus 3 is equal to 11 minus 2x, okay? If these two are congruent, we can set them equal again. So anytime we see that two things are congruent, we should have alarms, bells, whistles, anything going off in our head to say, hey, we should set them equal. If they're congruent, we should be thinking, hey, let's set them equal. Okay? Now, could you guys solve this problem? Yeah, okay. Let's go and solve it together though, okay? So, let's say we add 2x to both sides. Okay, there's a couple of different ways we can do this. So we have 7x minus 3 is equal to 11. What would be my next math move then? Jillian? What would you do now if I have 7x minus 3 is equal to 11? Okay, so what do we do with this negative 3? Add 3, very good. 7x is now equal to 14. How do we get x by itself now, Peyton? Divide by 7, very good. X is equal to 2. Were we asked just to find x though? No, Cole's saying no. Clyde, what are we supposed to find?
Bisector.
Okay, but we did that, so now what are we supposed to find? MQ. So we found x, so how can we find MQ now? Plug it in, right? We're going to plug it into here. 11 minus 2x. So 2 times 2 is 4. What's 11 minus 4? I heard it 7. Perfect. So the measure of segment MQ is 7. And that is our answer, along with that segment bisector being line L. Could we check that our answer is correct by making sure the other side is also 7?
Yes.
Yeah, I'm not going to make us do that right now for sake of time, but we could. Questions on that one, guys? Oh, okay. So here on example 13, identify the segment bisector of RS, then find RS. Let's just identify the segment bisector. This is a lowercase n, this is a lowercase n. So I want you to write down on your paper right now, the segment bisector is, I want you to write it down. I want you to write down on your paper what the segment bisector would be, okay? Please and thank you. Okay, so what's cutting segment RS in half? Is it a point? Is it a line? Gracie, what do you think it is? It's not a line, it's a ray. It has an end point, it goes forever in one direction. So it's a ray. And what do we call the ray? Ray n, lowercase n. Okay? Now we could find RS. What would we do with these two sides to find RS? Set them equal and solve, right? We aren't going to do that right now, but we could, okay? I want to go to the very bottom where it says midpoint, okay? I want to go to the very bottom where it says midpoint. So this is the formula to find our midpoint, okay? It's fairly straightforward. It's a little more simple than the distance formula, okay? I'll tell you that. The x-coordinate, okay? So we have our midpoint. It's the midpoint would be fashioned as, it'd be an x comma y, okay? A coordinate is like any coordinate, okay? The x-coordinate, the x of that, is the averages of x1 and x2. The averages of x1 and x2. The y-coordinate is the averages of, what do we think? Boom, y1 and y2, very good. Okay, the averages of y1 and y2, okay? So what we're saying here is this is a midpoint. This is our x, and this is going to be our y. That's what we're saying this is. So we're saying for the midpoint, if you take the averages, which is adding everything together and dividing by however many you had, so adding x1 plus x2 and dividing by 2 because you added 2 things, that's going to get your x. If you do the same thing with the y, that's going to get your y. That's why we have that comma here and we have it in parentheses, because it's a point. And we write our points x comma y. Okay? Okay. Hey, we're actually going to hold off there. Okay? I'm going to give you guys part of a homework assignment. We're going to get the other part next class, okay? I'm going to give you guys part of a homework assignment. We're going to get the other part next class, okay?
Probably on his GP. What?
What is that?
I thought those tiny.
So class,
Ian, put
I
my
want
phone
you
back
to
and
do
don't touch my stuff,
numbers
please.
1 through 8. I want you to do numbers 1 through 8. Okay, for next class, I want you to do numbers 1 through 8. Do not cross the rest out, but I want you to do numbers 1 through 8 for next class, okay?
Ow.
What if you're not doing it all?
If you're not doing it all, you can feel free to try it, okay? I think it's going to be a little bit tough.
Wait, what are we doing?
Okay, I want you to do numbers 1 through 8 for next class, okay? We'll do numbers 1 through 8 for next class. Okay? If you look on the front, numbers 1 and 2, you have to figure out whether the two segments are congruent. Or if not, which has a greater length. You're going to have to use, Skylar, you're going to have to use the distance formula for those to know that. On 1 and 2, you're going to use the distance formula, okay? You have to use it on a few of them. But heads up, on 1 and 2, you'll have to use the distance formula to find our lengths. Okay? We have to use math. You have to get to use math. How exciting, okay? Isn't that great? And you guys had me for Trooper Tie Tuesday. How exciting is that? Ooh. Hey, if you guys are ever struggling with math, okay, feel free to ask me to come in during advisory time / study hall time, okay? Feel free to ask me, hey, Mr. Charles, can I come in? I'll say, you betcha, okay? And you guys come in and then get help, okay? Don't be afraid. Also, before and after school, I'm available, okay? I do.
Mr. Fossil, do you know
Juniors.
Do you know the bus stop song?
Yeah.
Look it up real quick.